All right, so this is going on page 101 when we're done. Okay, so we have found inverses for our trig, but now we're going to actually use that to solve equations. Okay, so solving equations here. Because we are doing 5.8a before we do anything else in Unit 5, there is one little notation thing that I want to make sure that you understand, and that is if I'm going to take the cosine of x and square it, so like if I said, that what is the cosine of pi thirds? What is it? 1/2, okay? And then I would square 1/2 and I'd get 1/4, right? But that's not really the way that we write that we want cosine squared. The actual notation looks like this. Cosine squared x. It means the same thing. It means that you're going to find the cosine value and then you're going to square it, okay? So that's just the way it's done. So it's obvious that we're squaring cosine and not squaring the x. This is the way that you'll see it. But since you probably haven't seen it before, I just want to make sure you know what it is as we go into this, okay? All right, so when we're solving the equations, now in order to have an equation, you must have an equal sign. Don't forget that. We're going to start by graphing sine here quickly below. So if I'm going to graph sine, I have a point at 0, 0. At 2 pi it's a 0. At pi it's a 0. 1. I'm sorry, pi halves we're at 1. At 3 pi halves we're at -1. Some letters. Okay. Good enough for what we need for right now. So here it says, give these solutions to the equation sine of x equals 1/2. So if sine of x equals 1/2, then x equals the sine inverse of 1/2. What is the reference angle that gives me a sine value of 1/2? Pi 6, right? And what we learned last week with inverses is that we are restricted to 1. If I say, what is the sine inverse of 1/2, your answer is pi 6. That's it. But there are an infinite number of angles that give me a sine value of 1/2, right? We just had to be restricted because it was the inverse. So when you're solving equations, we still are restricted. Like if you were going to do this on a calculator, the only thing the calculator is going to give you is that pi 6. But then it says, I want these solutions, that's plural, and it gives me an interval from 0 to 2 pi. Okay, so if I'm looking from 0 to 2 pi, and sine is a positive 1/2, sine is positive in the first and the second quadrants, right? So there's actually 2 angles that work on this interval. So if you're just asked for the pure inverse, your answer is pi 6. If you're asked for the solutions on an interval, you have to give all of those possibilities in that interval. Do you see the difference there? It's like kind of like the pure math and the application of it, how to find it. All right, so let's look at what happens over here. First and second quadrant. Now, because of the way that I did this graph, if this is pi halves, this is pi 6, right? And so if this is pi 6, I'm at 1/2. I mean, mine doesn't really hit it. Yours probably might not either because we're sketching, but we're right there. But then you can also see that it happens again right here. And from 0 to 2 pi, you see how I have 2 answers? And my answers would be pi 6. And what is my second quadrant pi 6 angle? 5 pi 6. Okay. We good with that? Questions? So now this looks almost identical. Give the solutions to the equation, same equation, and this time the interval goes from -infinity to infinity. So there are not just 2 answers, there's an infinite amount of answers. We're going to work with defined intervals more than we are this, but I at least want you to know that this is a possibility and what it would look like. And you're kind of used to seeing stuff like this by now anyway. Oh, plus, no. X equals, all right, so I know I have one at pi 6. And then if I continue this, it's going to happen again 2 pi units away, and then another 2 pi units, and then another, right? So it's really pi 6 plus 2 pi n, where n is an element of the integers, but I don't have room to write all that, so we're just going to know that at this point. And then also at 5 pi 6 plus 2 pi n. And then that would take care of our infinite number of answers. Like I said, we're going to focus more on a defined interval than this, but you could have an infinite amount of answers. And this goes on to say A trigonometric equation, remember we have to have an equal sign to be an equation, can have one solution, no solution, or several solutions, depending on the defined interval. And several could mean like 2, it could mean an infinite amount. It could be anything. And then to solve a trigonometric equation, we isolate the trigonometric functions. The basic algebra stays the same. Don't try and make it hard just because there's trig in it. You know how to do basic algebra, you can do this just fine. It looks way harder, but it really isn't. Okay? So let's look at how this works. We want to isolate the trigonometric function. So the trigonometric function is cosine of x, right? I'll get cosine of x by itself before I can worry about x. So just like if that was a plain old x, I need to get all my x's on one side, everything that's not an x on the other side. So what do you want to move first? What? Square root of 2? Okay, so we can move the square root of 2 first. So 5 cosine of x equals 3 cosine of x minus the square root of 2. Okay, that really is the safest way to do it. I'm kind of glad nobody said to move. Of course, you might have been thinking it and you wouldn't be wrong. But if we move the 3 cosine of x first, that leaves 0 on the right-hand side, which is absolutely fine. But what happens to some people is when you move it and there's nothing there, then your equal sign disappears and you totally make up math. Okay, so it's safer not to move it if you don't have to. All right, so now I want to move the 3 cosine x. So when I subtract that from both sides, that's going to leave me with 2 cosine x equals negative square root of 2. Still trying to get cosine x by itself. It's being multiplied by 2, so I'm going to divide both sides by 2. So cosine of x is equal to negative square root of 2 over 2. So then I go look at my interval. I am going from 0 to 2 pi, the whole circle. My cosine value is negative. Cosine's only negative in the second and the third quadrants, right? So the first thing I want to think of is, what is the reference angle that gives me a cosine value of the square root of 2 over 2? Pi fourths. Okay, so now I got pi fourths in my head, but I need my second quadrant pi fourths angle, which is what? 3 pi fourths. And then my third quadrant pi fourths angle, which is 5 pi fourths. You see how that works? We're just going to base everything around that reference angle and then figure out what we need in what quadrant, okay? What questions you got? Anything? Okay. So let's look at number 2. I have 7 secant y equals secant y minus 4 square roots of 3. So what do you think we want to move first? Okay, if I move 4 square roots of 3 over here, it's not necessarily wrong, but then I'm going to have to move this over here. So is there, and again, it's not wrong, but is there another way to maybe keep things without all the negatives? Did I just move the secant y? I'm going to move the secant y over here. So I'm going to subtract secant y from both sides. I'm going to get 6 secant y equals negative 4 square root of 3. Now I have all my secants on one side. I'm going to divide both sides by 6. So I get secant y is equal to negative 4 square root of 3 over 6. Can I reduce that? Yes, that reduces to negative 2 square roots of 3 over 3. Now, we've been dealing with our reciprocals, but we really understand sine, cosine, and tangent better, right? So it would be nice if I could think of this in terms of sine, cosine, and tangent. What is secant the reciprocal of? Cosine. So then I can say this is cosine of y. That equals, what's the reciprocal of negative 2 square roots of 3 over 3? Square root of 3 over 2. Then I look at my interval. I'm going from 0 to 2 pi again. Cosine is negative again, second, third quadrants. What is my reference angle that gives me a cosine value of the square root of 3 over 2? Pi 6. So then I need my second quadrant pi 6th angle, 5 pi 6, and my third quadrant, which is 7 pi 6. Very good. See why I've been trying, one of the many reasons I've been trying to drill these unit circle values in your head, because you have to just know this stuff. What questions we got? All right. Let's look at number 3. All right, so I have 3 tangent of A equals tangent of A minus 2. So I think I want to get all my tangents on the left here. So, oops, if I subtract tangent of A from both sides, that leaves me with 2 tangent A equals negative 2. So tangent of A is equal to negative 1, right? So then I would take the inverse. I haven't been writing that, so you can stop here. If you want to write it all the way down to A equals the tangent inverse of negative 1, that's totally fine. I think I stopped on all those. I was going to do it on the first one, and then I didn't. Yeah. I mean, we're taking the inverse. We just didn't write that step, and that's okay. If you need to write it so you don't mess something up, that's fine too. Now we look at our interval here. I'm only going from pi to 3 pi halves, which is right there. My tangent value is negative. What do you know about the tangent in the third quadrant? It's positive. So there are no angles in that quadrant that give me a tangent value of negative 1. So A is the empty set. What questions do you have? All right. So let's look at number 4. So number 4 is a quadratic. Your first instinct with a quadratic should be to set it equal to 0 and see if you can factor it. So I'm going to move this 11 over, and this is going to give me 4 sine squared u minus 3 equals 0. So if I could factor that, that would mean it's a difference of squares. Is that a difference of squares? Is that first term a perfect square? Yes. Is 3 a perfect square? No. So it's not a difference of squares. So instead, I got to solve it a different way. So I'm going to move 3 over, and I'm going to get 4 sine squared u equals 3. Now, it's fine. I mean, maybe you could look at it and not actually write that step down and know you wouldn't get a perfect or a difference of squares. That's fine. I just don't want to lose you on your notes. So now that I have this, I can solve for sine. So I'm going to divide both sides by 4, and I'm going to get sine squared u equals 3/4. So just like any other algebraic anything, to undo the square, we're going to take the square root of both sides. So this is going to give me the sine of u equals the square root of 3/4, which is equal to the square root of 3 over 2. What am I missing? What? Plus or minus? The rest of you are going to math jail. Plus or minus? Plus or minus? Okay, if you introduce the square root, you put a plus or minus. Period, end of story. So now we look over here. We're going from pi to 3 pi halves. Well, sine is both positive and negative, so obviously I'm going to have an answer there, but I'm only going to have one answer. And what is the reference angle that gives me a sine value of the square root of 3 over 2? Pi thirds, right? Pi thirds in my third quadrant, pi thirds angle is 4 pi thirds. Good. What questions you got? Anything? All right. Let's look at this next one. All right, so 4 cosine squared x minus 1 equals 0. It is a quadratic. It is set equal to 0. I only have 2 terms, so the first thing I should ask myself is this a difference of squares? Is it? Yes, it is. Then I can factor it as such. This would be 2 cosine x plus 1 times 2 cosine x minus 1 equals 0. Okay. Factoring with the trig stuff, it's exactly like factoring when it's just a plain old x. Okay, all those factoring rules are going to stay the same. We're going to factor a lot. All right, so now that I have it factored, I'm going to use my zero product property. I'm going to split this off because there's a whole lot going on here. I know that 2 cosine x plus 1 equals 0, and I have to set 2 cosine x minus 1 equal to 0. So over here, this would give me 2 cosine x equals negative 1. So cosine x equals negative 1/2. Over here, I get 2 cosine x equals 1. So cosine of x equals 1/2. Then I got to look at what my interval is. So I'm going from 0 to 2 pi, right? So in this first one, cosine is negative. I know cosine is negative in the second and the third quadrants. What is the reference angle that gives me a cosine value of a negative 1/2? Pi thirds. What's my second quadrant pi thirds angle? 2 pi thirds. And my third quadrant? 4 pi thirds. Then when cosine is positive, that's in the first and the fourth. So that's pi thirds and what? 5 pi thirds, bless you. Okay, so those are the pieces of the answers. Then we put it all together, least to greatest. So this will be pi thirds, 2 pi thirds, 4 pi thirds, 5 pi thirds. What questions you got? Good? If you can factor with x's, you can factor with trig. If you still can't factor with x's, I don't know what to tell you. All right, let's look at number 6. Okay, so number 6, I have a quadratic also, so I'm going to set it equal to 0, so I'm going to move this cotangent over. So 0 equals cotangent x times sine squared x minus cotangent x. All right, so I only have 2 terms, definitely not a difference of squares, right? But then the next thing I look at is, do I have a GCF? I do. What's my GCF? Cotangent x. So I'm going to factor out that GCF. So 0 equals cotangent x times sine squared x minus 1. I still have a quadratic left in there. Now do I have a difference of squares? Yes, I can factor what's in those parentheses. So 0 is equal to cotangent x times sine of x plus 1 times sine of x minus 1. Any questions at this point? All right, so I have it factored as much as I can, right? So now I'm going to do my 0 product property. So I'm going to start off with cotangent x equals 0. But I want to think of that in terms of tangent. So if cotangent is 0, what is tangent? Undefined. Okay, and then I need to look at, let's see, we're going from pi to 2 pi. So from pi to 2 pi, when is tangent undefined? 3 pi halves. All right, so I'm going to skip a step here. Make sure you're okay with this. I know that I'm going to have to set sine of x plus 1 equal to 0, so I can just say I know that that means that the sine of x equals negative 1. Right, you can skip the whole equal 0 thing. Then from pi to 2 pi, when is sine negative 1? 3 pi halves again, right? And then this one will mean that sine of x, bless you, is equal to 1. From pi to 2 pi, when is sine 1? It's not, right? So that is the empty set. So from all of that, I really only have one answer, and it's 3 pi halves. What questions do you have? Anything? Nope. All right. So let's look at number 7. So I've squared again. I got a quadratic, so I'm going to set it equal to 0. I would like for my squared term to stay positive, so I'm going to move everything to the left. So this gives me cosecant squared theta plus cosecant theta minus 2 equals 0. Okay? Not a difference of squares, no GCF, but recognize this for what it is. It is a very simple quadratic. It would be the same as factoring x squared plus x minus 2. It's the exact same thing, okay? So a is 1. I'll open my parentheses. Since this is cosecant squared, this would be cosecant theta and cosecant theta. Make sure there's always an argument on your trig, like you can't just put cosecant. It's cosecant theta or cosecant x. This is negative, so the signs are opposite. Two numbers that multiply to give me 2, subtract to give me 1, be a positive 2 and a negative 1. Okay? Exact same factoring, right? Don't make it harder than it is because there's trig in it, right? Okay, so then I'm going to use my zero product property, which means here cosecant theta would equal negative 2. What is cosecant the reciprocal of? Sine. So that means that sine is equal to negative 1/2. My interval here, we're going from 3 pi halves to 2 pi. Well, sine is negative in that quadrant, so that's good. What's the reference angle? I forgot my theta after saying what I just said. What is the reference angle that gives me a sine value of 1/2? Pi 6. So my fourth quadrant pi 6th angle is 11 pi 6ths. Then I get that, oh, goodness gracious. Then I get that cosecant theta is equal to 1. So sine of theta is equal to 1. From 3 pi halves to 2 pi, when is sine 1? None. Right. So theta is equal to the empty set. Oops. Just for that part then. So then theta in the end is equal to 11 pi 6. We good on that? What questions we got? All right. This next one, I don't have a quadratic, and I have mixed trig stuff, especially since it's mixed. I think I just need to move everything over to one side, so I'm going to move it all over to the left since there's more over here. So I have the sine of x times the secant of x, and then this is 2 square roots of 2, and I'm going to subtract 1 over when I move it, so that'll just be plus the square root of 2 sine x equals 0. Not a quadratic, but do I have a GCF? Yes, I can factor out a sine. So I have that the sine of x is sine of x times secant x plus the square root of 2 equals 0. So now I have it factored as much as I can. I'm going to use my zero product property here. So I get that the sine of x is equal to 0. And I'm going from 0 to pi. So when is sine 0 from 0 to pi? 0 and pi. Okay, so then I get secant of x is equal to negative square root of 2. What is secant the reciprocal of? Cosine. So cosine of x is equal to, what's the reciprocal of the square root of 2? Square root of 2 over 2. So from 0 to pi, cosine is negative in the second quadrant. What is the reference angle that gives me a cosine value of square root of 2 over 2? Pi fourths. My second quadrant pi fourths angle is 3 pi fourths. Very good. Then I put all that together. Say that x is equal to 0, 3 pi fourths, and pi. What questions you got? Okay. Okay. We raising hand? Now on number 9, I got lots of stuff going on that I think I'm going to have to factor, so I'm going to move it all over to the left since I have the secant to the fourth here. So secant to the fourth, x. So I have minus 4 secant squared, and then I have another secant squared I'm going to move over. So that's minus 5 secant squared x, and then I'm going to add that 1, so that's plus 4 equals 0. So this is a quartic, but a is 1, and it's set up like a quadratic, so I can factor that. We factored it with x's. We can factor it with trig. So I'm going to set up my little parentheses here. Since this is secant to the 4th, these are going to be secant squared x and secant squared x. This is positive, so the signs are the same. This is negative, so they're both negative. Two numbers that multiply to give me 4, combine to give me a negative 5, be a negative 1, and a negative 4. Can I factor some more? What are these? Difference of squares. So I get secant of x plus 1 times secant x minus 1 times secant x plus 2 times secant x minus 2 equals 0. Oops. Then I can use my zero product property here, and I get that secant x equals negative 1. So cosine x equals negative 1. I'm going from pi to 2 pi. So in that time, when is cosine negative 1? At pi, good. So then here I have that secant of x is equal to 1. So cosine of x is equal to 1. From pi to 2 pi, when is cosine 1? 2 pi. I'm only going from pi to 2 pi, so my answer has to be 2 pi. So make sure because 0 is the correct answer, but not for this problem. All right, so then I get that secant x is equal to negative 2. So cosine x equals negative 1/2. Well, cosine is negative in the third quadrant right there. What is the reference angle that gives me a cosine value of 1/2? Pi thirds. So then my third quadrant pi thirds angle is 4 pi thirds. Then I have that secant x equals 2, which means that cosine is 1/2. Cosine's positive in the fourth quadrant. I know it's a pi thirds angle. My fourth quadrant pi thirds angle is 5 pi thirds. So then I just do all this, least to greatest. I start with pi. Then I have 4 pi thirds. I have 5 pi thirds. And I have 2 pi. Okay. What questions you got? All right, number 10. I have 4 terms, and it's set equal to 0. How do I factor something with 4 terms? Grouping, yes, grouping. Grouping. So I'm going to group these two. Hey, at least I know you know what you're talking about. That's all good. I'm going to group these two and group these two. Yeah, knowing the phrase, knowing that it's called grouping is not as important as knowing what to actually do. So you're good. So in these first two, I can factor out a tangent squared. So I've got tangent squared y times tangent y plus 1. Out of the second two, I can factor out a negative 3. That leaves me with tangent y plus 1, and that equals 0. So then that means I have tangent squared y minus 3 times, I forgot my y there again, tangent y plus 1 equals 0. All right, so in that first set of parentheses, I still have a squared. Is that a difference of squares, though? No, so I can't do it. I can't factor it anymore. I mean, I could, but I just want to solve from here. So from here, I know that tangent squared y is equal to 3. That means that tangent of y is equal to what? Close. What do I have to write first? Plus or minus. Plus or minus the square root of 3. My interval here, I'm going from 0 to pi. So tangent is positive and negative in that range. So I just need to think about what is the reference angle that gives me a tangent value of the square root of 3. pi thirds. So I need my first quadrant, which is pi thirds, and then my second quadrant is 2 pi thirds. Right? Then here I get tangent of y is equal to -1. Tangent's only negative in the second quadrant in that interval. What is the reference angle that gives me a tangent value of 1? Pi fourths. So then I need my second quadrant pi fourths angle, which is 3 pi fourths. Good. So then I have y equals pi thirds. Which one comes next? 2 pi thirds. Good. You should be able to picture it on the unit circle, right? You don't really have to think about fraction values. 3 pi fourths. All right. What questions do you have? We good? You can do this. You can do this. You need to be able to read your own writing and not lose yourself and stuff, but you can do this. Remember, the assignment that goes with today is a Delta Math, but I am going to give you the worksheet for tomorrow just in case I don't see you.